Thank you all the attendees here in the room and also online. I have seen many famous names also online, so it's very exciting to do this presentation. And it's, as you can imagine, a super hot topic. It's done in collaboration not just with Thomas, that he will present after me, so we continue the presentation. It's also done with Gustav Eichinger, that is online, Alexia, that just presented the introduced us, and Stefan Ratschek, that he's working at the US.
So it's a true Wittgenstein Center collaboration.
Yeah.
So I start with this nice slide. So on the left-hand side, what we can see is the evolution of the total fertility rate from 1950 until 2100. It's based on the UN World Population Prospects. And what we can see is that more or less around the 70s, many countries started, and many regions started experiencing a decline in their total fertility rate. And what we can see in the dark red line, this is for the world, so the evolution of the total fertility rate of the world. And this trend is right now a very hot topic. Many people are already panicking about potential depopulation because the TFR at the world level is approaching to below replacement level. And this has already happened in many countries in the world, even in middle and low income countries. Now, what you can see here is that this panic is not just coming from politicians, that they are urging people to have many more children. It's also coming from many journalists and also from the social media nowadays. So here you can see a quote about what Elon Musk is saying, that he thinks that population will collapse. But of course, demographers are saying, well, let's see what is happening. This is our intention now, today. Another thing that is that researchers, scientific writers, and also economists, they are already writing a lot about the potential consequences of the population decline. And what we can see right now is this group of people that they are thinking about long-termism, that they are right now associating the declining population with all kind of bad economic consequences, whereas they associate the increase in the population with very positive consequences, rapid innovation, and so on. And this is like a reminder of what was happening already in the field, in the field of economic demography, in the second mid part of the 20th century, about the economists that they were thinking that the increase in population was having a positive effect, so the positivists, also those that they were thinking that it was having a negative effect, that they were coined as the negatives. But in the 90s, there was already reached a consensus that in the long run, these kind of trends, even if it's declining or increasing, will have a neutral impact on the economy. It's only during the transition. And this is the neutralist group, that it was the school of thought from Harvard, starting with David Williamson, David Bloom, and Canning, and Jeffrey Williamson, sorry. David Bloom and David Canning, that they were establishing the first demographic dividend. So in principle, we were reaching already a consensus, but it seems that this, again, negative point of view of changes in the population is coming back one more time. Also, politicians, politicians are trying to push people to have many more children, and one of the ways of showing what can be the negative consequences and promote people to start having children is what is done, for instance, in Japan. That Japan right now is the leading aging country in the world, and the one that is already declining for a few years, I mean decades. And what they have calculated is what is the doomsday clock. And they are trying to estimate what will be the year in which the last birth, the last Japanese birth will occur. And they're estimating that by the year 2677, that will be the very last Japanese being born. So this is for raising awareness of start having many more children than they are having at the moment. So some of the things that we need to do from time to time as researchers is trying to do some need busting. And this is what, right now also very hot in research, do some need busting. And we were already doing this with this very similar topic. It was about the aging process. And the famous scientific writer Fred Spears wrote a book, The Coming Population Crash, and also published in The Economist this quote saying that it's possible that 50% of all people who have ever been over 65 are alive today. So in order, what we wanted once that we saw this, especially Gustav, that was the one who was promoting the idea, was like, okay, for me it's too high, so let's try to come up with a model, a demographic model, that we can assess what is going to be the proper value of all people who have ever been over 65 and are alive today. So what we were developing is a general invest population projection that was developed by Jim and Roland Lee in the 80s. And based on all the historical information from many other scientists, demographers, who were already studying this topic, we came up with what is the potential highest number of population ever lived and the lowest number of population ever lived in order to have the proper bandwidth. And we were estimating that the fraction of all people over 65 ever lived today is relative to the historical past, is around 5.5 to 9.5. So this is a clear need busting that this number is not as high, so it's much lower. So one of the goals in this case is trying to assess whether what is being said in the media and by politicians is correct. So something that we need to be aware when we are doing this kind of analysis is that this fear of population decline is nothing new. So we know that there were many population declines, not just because of the Black Death. They were also driven by declines in fertility, because of out-migration, and also because of political or environmental upheavals. So there were sudden crises that were leading also to changes to declines in the population. So, for instance, in Ireland, during the Great Famine, the population directly halved over 80 years. During the peacetime in several European countries, we also see declines in fertility and declines in population, but they were partly driven by fertility, but also partly driven by out-migration. And one of the typical examples that is being shown is because we have very good historical records, is the case of Sweden, that we see already in the peacetime between the two world wars, fertility that was below replacement level. In France, there is also at the end of the late 20th century a decline in the population, and the government at that time they were already having fear of population decline, and they were promoting pro-natalist policies. And something that has come like a more public awareness in the world was the experience, the recent experience of Eastern and Southeastern European countries, for which, due to out-migration and also the decline in fertility, they are experiencing a huge decline in their populations. That is around between 20 and 35%. Now, why is getting so much attention during the last years this topic? Partly is because compared to the past, so the rapid population decline has already been happening in the past, but now we also are experiencing in many countries ultra low fertility. So people think about the case of South Korea, for instance, that South Korea right now the TFR is around 0.7, and in Seoul is around 0.5. There is a growing number of countries already experiencing population decline, and I will show you a figure that shows when the population decline will occur in several countries based on the UN population projections. There is more attention from media on this topic, and there are many scientists, and there is a much higher population debate about this topic. But there can be also a lot of misconception, and because the decline in fertility is not just the only driver, there can be many other drivers. So here, as I said, we have a nice plot that is showing when the population is peaking in the world, in each specific region in the world, and this is based on the United Nations population projections. And what you can see that in many countries here in Western Europe, in Europe and Eurasia and in China, the peak has already been reached, and it's going to start declining if there is no migration much higher than the one that is being projected by the United Nations. It will peak in most of South America in the next quarter, and it will still grow in several other countries around the world. And of course, Demography has already been doing many population projections based on different assumptions. And here, our colleague Stuart Basten, he's not working here, but we know very well, Stuart Basten, Wolfgang Lutz, that is the previous director of the Miguel Science Center, and also Sergei Sergov. They were calculating already in an article published in Demographic Research in 2013 the potential population projections for different fertility levels. So this is nothing new, so we have been doing this for decades already. But something that is interesting to see in this case is that based on the information that it was available for the UN population projections until 2013, if you see the population numbers, the TFR that will correspond to the current population level will be much higher based on these projections that we have right now. So there is a lot of uncertainty in these calculations. So they were projecting based on the current TFR much lower population values. So we need to think that there are many other processes, so mortality also plays an important role in this calculation. So there is a large uncertainty.
I'm sorry, if we did this today, why would it look different? The future will still be the same.
I will show you later.
But I don't understand what you just said.
Because today's numbers look higher than what they projected for 2025.
But this is just a projection of
base
starting in 2000.
And so if we start in 2025,
they were already low in their projection for the current period for some reason.
but these scenarios are switching to the ultimate rate immediately,
Yes.
or gradually?
I think immediately.
20, 30, 50, it's that.
Okay. So we're a different path to that.
Yeah.
Okay.
A quick pass to that, yeah.
Okay. Thank you.
So we have this very famous figure from Dean Pierce and collaborators about what is the historical population size and how it has peaked it shouldn't be peaking in 2023, it should be peaking afterwards. But anyway, what they are trying to raise the awareness of what is happening by showing this specific graph that if things continue being under replacement level, that it seems that the population will go extinct.
But look at the scale on the axis, from minus 10,000 years until plus 4,000 years.
So there is a lot of trick in the plot. So what we will try is to show, here on the axis, of course, is not completely right. The evolution is possible, but we will try to assess exactly what is going to be this evolution and whether there will be a demise of the population and when this will happen.
What is wrong with the axis?
So these are
10,000 years.
5,000 years here. This length does not correspond well.
You mean it's not actually a linear axis?
No,
No, look, there's 4,000 on the right-hand side.
So,
I mean, what you're saying is. very
Hi, I'm an
serious.
author on the paper. The axis is linear.
Because the distance between years are not equal on the graph, but I don't think that, to the viewer, it doesn't seem that.
To me, it looks almost plausible.
I mean, it's potentially possible. we will show you. We will show you.
From one.
So I retract what I said. Because it's.
I mean, there's the place they put the labels and things like that, you could argue about the actual linearity of the scale.
Yeah. So we will try to assess. We can show some similar plots to this, and I can show you more detailed information, even by age, after the talk. So our aim with this presentation will be calculating the future evolution of the number of birds and also calculating what is the fraction of birds that we are expecting in the future relative to the past. What we are going to derive is an analytical framework for doing the analysis and trying to understand what are the main demographic components that will explain what is going to be the evolution of this fraction of birds expected in the future. Also, we are going to try to assess when humans will extinct based on the demographic projections that we are going to do, and we are assuming that the extinction will occur when the total number of birds for the world population will be below 1,000. Okay? So we are going to calculate what is the last year when the total number of birds will be above 1,000. And we are going also to consider what is the role of intergenerational length on these estimates. So this is exactly the fraction of interest in our case. This capital B will correspond to the total number of birds in year t. Time t will be exactly the period from where we are going to do this analysis. And here in the denominator, what we have is the expected total number of birds that will be born. And based on the stable population curve, so if we are assuming that from time t on, the population is already stable, what we can show is that if the intrinsic population growth rate is positive, then this ratio will be equal to 1. So almost all birds, except for an epsilon, marginal epsilon, will occur in the future, but if the intrinsic population growth rate is negative, then what is important is to analyze this ratio. And this ratio, what we see is that depends on this theta of t, and is divided by 1 plus theta t. And the theta is the ratio of future to past birds in year t. Now, and these are the only 2 slides with math, don't worry. What we have is that with continue using the stable population theory, if we simplify the theta, what we are obtaining is that it will depend, or it's going to be given by this ratio, that is the current number of birds to the total number of people ever born, and it's going to be 1 minus the population growth rate. The population growth rate in this case is negative, so this ratio is positive. Okay. Now, what is really important to keep in mind is that in a state, the intrinsic population growth rate is approximately equal to the log of the net reproduction rate. So the net reproduction rate is the number of baby girls per woman, but also taking into account mortality, and divided by the mean age of childbearing. And as Dini and Constant that is here, that was speaking before, they were already saying that a longer generational length will slow down the path of population. So, both. So it's population change. So this figure clearly shows what is the association between the total fertility rate and the population growth rate. This area corresponds to above replacement level, so was that we are going to have a positive intrinsic population growth rate. This white area corresponds to the area that will have negative population growth rate. And what we can see is that whenever that there is an increase in the mean age of childbearing, the rate of population change can be diminished by the mean age of childbearing. So a higher mean age of childbearing when we are in the with the area with a positive population growth rate will imply a decline in the population growth rate. But if we are in the area where the population growth rate is negative, then there will be a slowdown in the decline in population growth. And this will be really important to keep in mind. Now, what we have done is using this theoretical model to analyze empirically, based on the UN World Population Probabilistic Projection, where we are going to keep the fertility rate indefinitely from the year 2100 on, so not in 2024, but in the year 2100 on, what is going to be this fraction. And we are also going to do some sensitivity analysis considering a wide range of very low fertility, with a specific set of assumptions that Tomas will specify. Now, how we have constructed the data? We have taken information from this table A2 from the article that we previously published in Demography Research, where we were estimating the highest and the lowest total population ever lived until the year 2013. That is based on the calculation from Howe and Nimini until 1960, and is fully consistent with the initial population structure from the UN. This from 1960 until 2013, we are using directly the data of the UN. And what we are obtaining is that around 112 billion, 113 billion people have ever lived, if we use the assumptions from Howe, 2011, and 77 billion people have ever lived until 2013, if we use the assumptions of TV. And we will continue with the UN World Population Predictions until 2024. That this will add around 2 more billion people, so 2 more billion births. And from then on, from 2024, we will use the UN World Probabilistic Population Projections, and after that until 2100, and we will continue with the model, assuming the fixed fertility rates from 2100 and no mortality before menopause. The estimates of the mortality before menopause in the case of using the UN will be around 0.99 and a value, but it is not very close to 9, but it is much lower to 0. It is much closer to 0, but still, if we are thinking that there will be still increases in technology and so on, we can expect that also there will be continued continued increases in survival. So that's the reason for assuming that there won't be any mortality phenomenon. I can show you also estimates doing using cohort projections with the data with mortality after the resurrection. Now, this is the UN World Population Projections distribution for the total fertility rate. So what they are providing are 5 different numbers. These 5 different numbers are here, written here. So, and is based on a specific percentage. So the percentage that they are using is the upper 95, upper 80, the median, the lower 80, and the lower 95. So for the very first two, we will have above, so we will have intrinsic population growth rate that is positive, and for the other 3, we will have a negative. So we will mainly focus on these 3 other ones. And here you will see what will be the implication for the net reproduction rate. So whenever the net reproduction rate will be lower than 1, that will imply that the intrinsic population growth rate will be negative, and vice versa.
Can you explain the distribution here is across populations, or is it for the world?
It's a probabilistic distribution of total fertility rate for the whole Earth in 2100.
So the world will have one future fertility rate, and since it's random, it can take any of these values.
Yes.
Okay.
And the annual and the mean age of childbearing that we are they are assuming is around between 29.5 and 29. So now I will give the floor to Tomas. And
Thank you, Miguel.
enjoy.
I hope we are still okay this time. Can take, how much time can I take?
Maybe if you manage in 10, 15 minutes.
15 sounds better then. Okay. So we have mean age of childbearing around 30 in both projected but also in contemporary populations. That would be a typical mean age of childbearing. But what is the realistic range of the mean ages the childbearing we can play with? Looking at the actual populations observed in the past and at present, I think the values of the mean age of childbearing between 25 and 35 is what you can observe in empirical populations. 25 would be Bulgaria. 30 years ago, everyone starting early and many people having 1 child or 2 children max. 35 would be what you observe in Seoul, South Korea today, a place with a very late start of parenthood, but also most people having just 1 child or 2 max. But we are also considering a kind of sci-fi scenario from another world. What happens if women have children at extreme late ages, extreme late reproductive ages, 50? What happens if everyone is freezing their eggs half a century from now and doing a lot of other exciting things before they decide, okay, now it's time to have kids, when they are somewhere in their midlife and they are reaching 50? So that's of course not realistic from today's perspective, but we want to play with the data and scenarios. There are some assumptions behind what we are doing. We are completely ignoring the negative effect of later childbearing on infertility, on fecundity. So that's a simplification for our model. Of course, we are aware that delayed childbearing means that a lot of people don't achieve what they want because of infertility. To simplify our calculations, we assume that all kids are born right at the time when people are hitting the mean age of childbearing. So all our kids in our model are born either at 25 or 30 or 35 or 50, depending on the scenario. And we are not accounting for the tempo effect, which happens when we need to shift from the current mean age of childbearing of 30 towards the projected mean age of childbearing. So we didn't do this calculation. So what's the total number of future births according to different scenarios until the year 3000, year by year by year? If you take the UN upper 95 and upper 80 percentile scenarios, of course we get a continuous increase in the number of births. If you take the other scenarios, the number of births is declining gradually or a bit faster and you see that by the year 3000, there are not so many births left even in the median scenario. So the lower tens of millions or even millions. So what would be the fraction of total human births which would occur in the future based on these scenarios? Upper 80 and upper 95, of course, almost 100% of all births will happen in the future because things keep increasing indefinitely. That's just the property of the model. If you look, that's more interesting, to the median, lower 80, lower 95 percentile scenarios. There are some differences on whether you take Haupt's estimate of past population or Dewey's estimate. Let's concentrate on Haupt, and let's say that this lower 80, lower 95 percentile scenarios, only about between 15 and 20% of all births which will ever occur in humanity would be born in the future. So not so many. Most of the things would, if things continue in this way indefinitely, most of the births are already born, most of the humans are already born by now. What happens when we start playing with different mean ages in childbearing? So again, if you start thinking about the fraction of people who will be born in the future, and now we have the total fertility rate here, down on the x-axis, and the fraction of all future births related to total births in humanity, in human history, you see quite some differences depending on the mean age of childbearing, especially if we take the extreme scenario of very late mean age of childbearing at 50. You can see it also in the next graph. This would be the total number of births to happen in the future. And interestingly enough, if we, for instance, look at the medium scenario corresponding to the TFR 1.84, this every 5 years of later mean age of childbearing, we gain 5 billion additional births in the future. So that's quite a strong impact. This mean age at 25, you would have 35 billion births in the future. With the extreme mean age at 50, we would have almost the double, 60 billion births in the future. So here you can see the sensitivity of the mean age of childbearing. You can see another interesting thing with low fertility rates, and it would be even stronger the lower you get. The impact of the mean age of childbearing in the absolute and relative terms is smaller than when fertility rate is higher and closer to replacement level. Now, what would it mean for the year when humanity would be equal to today's pandas or white tigers, and there would be just thousands, tens of thousands of people left, and the last year when more than 1,000 kids would be born? So let's look at the extremes in here. Is the TFR 1.6 corresponding to the lower 95 percentile of the UN projections, and very early childbearing at 25. This date would occur in 3,247, so 1,000 years from now. If we shift towards the UN medium scenario, and we consider the extreme age of childbearing of 50, of course, not realistic at all, this would suddenly shift to the year 7,374, so some 5,000 years from now. So both, of course, fertility rate, even small differences in total fertility rate make a big difference in the year when humans would be close to extinction. But then, combined with the differences in mean age of childbearing, this also makes a huge difference. Now, what about the extremes? You could say, look, UN is extremely conservative. 1.6 today doesn't sound like a very low fertility rate, saying that this is the lowest 5% of the distribution of plausible future fertility rates. They are just too high. And you may be right. So, of course, once you start playing with much lower levels of the TFR and we go down to the level of 0.5, the time horizon for humans to disappear becomes much closer to today, and things start happening already in this millennium, in the next centuries, and not in the next one. For instance, when you look at the evolution of total births with the TFR of 1, we would get close to zero somewhere at the year 2,700, so 500 years from now. And I think it's kind of possible to speculate about that. So that's the empirical results we got. We have to emphasize again, this is a very hypothetical exercise. It's an extreme long-term horizon, a kind of thing demographers want to see, but we never have stable mortality and fertility rates. So we know that things are changing every couple of years, and the projections get old even after 2 or 3 years sometimes. So keep it in mind, this is an exercise with a lot of simplifying assumptions, and it has nothing to do with how real things will unfold in the future. The very general insights about long-term population trends and disappearance with very low fertility are actually in line with some of the previous studies, including the Spears and Corey study. But I think our main novelty is to show the cumulative impact of intergenerational length illustrated by different mean ages in childbearing, how strongly it would affect population trends in the very long term. I think we have convinced you that later mean age at childbearing has a powerful impact in the long run when populations are declining, and they lead to, later childbearing would lead to more future births. It would postpone the date when humans would become extinct. As I mentioned, this impact is stronger when fertility is moderately low rather than extreme low. I think we also demonstrated that in most of the fertility scenarios for the future, humanity's hypothetical extinction occurs slowly, especially when one works with the UN fertility scenarios, happening in the next millennium or somewhere after that. There will be much faster turbocharged depopulation, of course, with extreme low TFR values persisting everywhere indefinitely. For the future, I think we can explore a little bit more the effects of the extreme low TFRs on future trends. We didn't build these extreme scenarios into all the results we were showing you. And it would be fun to look also at individual countries when things, of course, would happen earlier and more dynamically in many cases. But should we be worried about humanity's looming extinction following the argument by Elon Musk? I think we have a couple of small crises to worry about before humanity really will reach such small numbers that we should be obsessed about it. Thank you very much.